All right, guys, welcome. For oxy-fuel cutting. Okay, lesson 2 objectives. You'll identify and describe oxy-fuel cutting equipment and consumables. It can explain how to set up, light, and shut down oxy-fuel equipment. Okay, this PowerPoint here relates directly to the video that you guys are creating for oxy-fuel setup. Okay, there we go. Performance tasks. Set up the oxy-fuel equipment. Okay, tip cleaners, drill kits, and friction lighters. So these are just a few of the tools that you need that are kind of supplemental and normal wear items. They're going to go along with your cutting torch. Tip cleaning kit is a series of small files used to clean out the orifices on the cutting and welding tips. Be real careful on those with the smaller diameter files, as they can break in there. So don't force it. The tip drill is very handy to get out, really tough carbon deposits. And then the strikers there, those are two types of strikers, just friction strikers. So it's just kind of like a striker on a Bic lighter. But never use a Bic lighter to light a torch. Cylinder carts and soapstone markers. Okay, so we've gotten our hands on our cylinder carts here, and as you can see, they have 2 cylinder carts, and the green one is a very traditional one. Then the yellow cart there has the 30-minute fire barrier as required by OSHA. Got a couple different soapstone holders there. The one on the left is for holding a flat soapstone like we have in the shop. The one on the right is for holding round soapstone. My personal favorite when working with mild steel are the silver graphite pencils. They also make another style that I own that holds just almost a piece of the silver graphite, kind of as like a piece of lead, similar to a lead holder like you'd use kind of in very traditional drafting. But that's my favorite when working with mild steel. A motor-driven equipment. A computer-controlled gantry cutting machine provides repeatable accuracy and high production levels. So this is basically just a CNC cutting machine, but using an oxy-fuel torch. One option I wish we had on ours, actually, for cutting heavier material. When you guys start out cutting, you'll notice it's a little rough. But when you cut with a machine like this, and you can keep a consistent speed and height, oxyacetylene actually can cut extremely clean, especially on thicker materials. Motor-driven equipment. Track burners also provide straight line accuracy. They can make bevel cuts as well as square edges. Yeah, track burners are extremely handy for long straight line cutting, and can be used to break down larger sheets of material and making really nice straight line cuts. There's a few different options out there for these. Okay, here's a band track pipe cutter to provide consistent cuts in the field. I've never actually seen a band cutter like this. I do know that there are some cutters that'll clamp on. You hand crank them to move the torch around. Some beveling machines that guys will use out in the oil fields for smaller pipe. This pipe pictured is quite large. Okay, exothermic oxygen lances. An exothermic oxygen lance is a special cutting tool that creates temperatures approaching 10,000 degrees Fahrenheit. Okay, burns extremely hot, and again, guys, some of the specialty equipment that we cover and talk about, we don't use it here. If you do use it, your company will provide the specialized training. All right, now in section 3, we look at the setup. Okay, you want to be careful, when you're inspecting these, make sure there's no signs of damage and wear. Where these fittings made up those machine surfaces, small nicks can cause leaks. That's why it's important to check for leaks. Just remember, all your oxygen connections are going to be right hand. Your connection to the tank is going to be a going to be a female right hand. Fuel gas is going to be left hand male. Okay, using the right tool for the job is a craft worker's model. Always tighten the regulation connectors using a torch wrench. Okay, guys, sometimes the torch wrenches are junk, so sometimes we got to do what we got to do. You want to attach the regulator. You don't want to cross thread the nut when you're tightening that up. Hold the regulator in place with the seating surfaces mated up, and then gently screw the nut in place and snug. You don't want to tighten it. You don't need to torque it to, really tight. Okay, crack the cylinder valve slightly and turn the pressure adjustment screw to allow gas to pass through and expel any debris. Then shut the cylinder valve and close the regulator. Okay, remember, we're not going to install any flashback arrestors. We have those. So we're not going to attach any of those on the hose. Those are in place on the torch. The flashback arrestors must be installed on the fuel gas and oxygen connections of the torch unless the torch has built-in flashback arrestors and check valves. Okay, installing the cutting tip. One thing I failed to mention during the setup, you want to be extremely careful handling the cutting tip. There's two seating surfaces where that tip goes inside the cutting head. If those get a small nick on them, you can actually hear it. When the torch runs, may have a small popping sound, almost like a clicking, that's caused by that. So you want to make sure that that it's in place firmly, then tighten down the tip nut. Okay, torch and regulator adjusting screws. To prevent damage to the regulator diaphragm, back the regulator adjusting screws all the way out and close the torch valves before opening the cylinder hand valve. Okay, just remember, on the older regulators with the T handles, we don't want to back those out too far. We just want to back them out until the pressure is off the diaphragm. Testing for leaks. Okay. Proper leak detection fluid makes the discovery of escaping gas easier. Do not use detergent that contains oil. Oil mixed with oxygen is a recipe for disaster. Okay, remember, your quick and dirty way to check for leaks: shut the system down, watch the head pressure gauge. As it falls, that tells you have a leak. Then a soapy solution with a non-oil based soap can be used to then check all the connections and fittings to find out exactly where the leak is. Okay, leak testing points. You have the oxygen regulator connections. It could be where the gauges connect to the regulator. Just any place you have a screw connection on the regulator, on the hoses, on the torch. Could even be the hoses themselves. Okay, full leak test. Leaks are most likely to be found at the point shown. A leaky torch is a serious hazard. Consistent testing is necessary. Okay, so there's three basic types of flames. A neutral flame burns properly, proportions of oxygen and fuel gas, light blue inner cones, surrounded by a dark blue envelope, used for most cutting. Carburizing flame has a white feather created by excess fuel. The outer flame envelope is longer and much brighter in color. The excess fuel in the carburizing flame produces large amounts of carbon, never used for cutting. Oxidizing flame has an excess of oxygen. The inner cones are shorter, much brighter in color, and more pointed than the neutral flame. And oxidizing flame is the hottest flame, but is not typically used for cutting. Okay, here's a picture showing the different flames. On the left is going to be all oxyacetylene. On the right is oxypropane. Okay, backfires and flashback. Backfire causes improper operation, loose torch tip, dirt in the torch tip seat, or a bad seat. So this is where you have fires internally within the system. A flashback is where the fire actually starts to travel up the hoses. This is equipment failure, overheated torch tip, dross or spatter hitting and sticking to the torch tip, oversized tip, too large a tip for the gas flow rate. Shutting down oxy-fuel cutting equipment. You're going to close the cylinder valves first, leaving the regulator and torch valves open at this time, allowing all the pressure to bleed from the hoses and the regulator. And then at that point, shut everything down, back the adjustment screws off. Okay. Let's see if this video will work. It doesn't look like the video works. Okay. All right, guys, I have a video though for you to watch. All right, stay tuned for session 3. What's up, Junior?